Today we're going to be talking about chemical reactions, chemical equations, and acids and bases. Just to start off, chemical reaction is a process that changes from one substance to a new substance. So that new substance doesn't have any characteristics as the old substance. It has its own new characteristics. And the chemical reactions are usually shown by a chemical equation. There are four signs that a chemical reaction has occurred. They are color change, formation of precipitate, formation of a gas, and temperature change. Color change in this picture is metal that's been rusted, so it's got iron oxide, iron that has now oxygen enriched in it, so it's now a little bit of red. The precipitate, as you can see, is a yellow liquid before it goes into the solution, and now it's a yellow cloud, and that's making some kind of solid inside. We also have a formation of a gas that looks like some kind of metal inside, like an acid or something, and it's forming gas bubbles. The right bottom, the temperature change, looks like magnesium strip being burned at a very high temperature. So that's a magnesium strip at room temperature, and then when it is being burned, temperature increases. So it's an exothermic reaction. We're going to talk about law of conservation of mass or matter, kind of interchangeable. Matter is the amount of mass is the amount of matter in an object. So conservation of matter or mass is what you would see it as. This law states that atoms are not created nor destroyed in a chemical reaction. All the reactants are equal to all the products. The left side or the right is equal to the right side of a chemical reaction or a chemical equation. You can see down here in the bottom we have a balance. So all the reactants that would be on the left side here need to be equal to all the products on the right side. That means all the atoms, the weight of the atoms need to be equal on both sides. So this is a chemical equation. You might be familiar with what's up here at the top. We had 2Mg plus O2 gives you 2MgO. So the left side of the reaction is called the reactants. Just whatever's on the left side of the arrow, that's called the reactants, and the right side of the equation, whatever's on the right side of the arrow, are called the products. Sometimes you'll see an arrow in the middle going both ways. Sometimes you'll see it going one way. This is yields or produces. There's many different words to explain it, but we're just going to use the word yield. The two here on the bottom of the O, on the right side of the O, is called a subscript. And what that means is that there's two oxygen atoms coming in the oxygen molecule. So if I had magnesium 2 here, there'd be two magnesium atoms in a magnesium molecule. But magnesium comes individually, one atom at a time. Oxygen comes in a group of two when it comes out. And there's some other stuff that comes out in twos, like iodine and bromine and fluorine. So there's more than just oxygen, but this is a group of two oxygen atoms as one molecule. The other number in front of the substance is called the coefficient, and that tells you how many molecules there are, how many groups of MgO there are. So MgO would be one group, and there are two groups of them, two groups of MgO, two molecules of MgO, or two molecules of Mg in this situation. So just to explain this a little bit easier, we're going to talk about hot dogs and making hot dogs. So when you go to the store and buy hot dogs, you're always going to buy buns separate from the hot dogs, and together they make a hot dog bun combo. So the left side we're going to talk about being the reactants, the right side talking about being the products. So the situation that we have here is that buns come in a pack of 8, and hot dogs come in a pack of 6. And this causes very much confusion when you are going to buy them, because you're not always going to have the same number of buns to hot dog ratio. So we need to figure out how many bun packages or bun molecules and how many hot dog packages or hot dog molecules that we need to have so that we have an equal amount of bun to hot dog ratio is what we're looking for. So just a little information. The 8 represents the number of buns in a package, and the BN is a symbol for buns, just like the 6 is the number of hot dogs in a package, and HD represents hot dogs. So if we really think about it, we have 8 and 6 being our packaging. The way we can find out how many packages we need is we need to find like a least common multiple between 8 and 6 in this situation. So 8 and 6, the least common multiple is 24. So then we have 8 in a package, 3 packages. 3 times 8 is 24 buns. And then we have 4 packages of 6 hot dogs per package. That's 4 times 6 is 24 hot dogs. Together we get hot dog bun combos, 24 hot dog bun combos. Equal amount of hot dogs to bun ratio is exactly what we want. And the left side is equal to the right side, as you can see here. So how do we apply this to more realistic chemistry situations? We have hydrogen and oxygen here. Hydrogen comes in groups of 2, just like I was telling you about oxygen. H2 for hydrogen, O2 for oxygen. Well, those come in groups of hydrogen and oxygen, groups of 2. So you need 2 hydrogen 2 molecules. So one molecule, one group of 2 hydrogen, another group of 2 hydrogen. So 2 groups of 2 hydrogen, and one group of oxygen 2. So one group of oxygen. And this will produce 2 molecules of water. The oxygen split up, and the hydrogen split up and attached to oxygen. So the oxygen split up into separate molecules with 2 hydrogen attached to each oxygen atom. Let's continue on to acids and bases. Acids and bases are about solutions. A solution is a liquid form of a solvent and a solute. So acids and bases are in everyday things, chemicals, cleaning supplies, and so forth. So generally a compound that is an acid or a base acts as an acid or base only when it is dissolved in a water. When it's in its solid state, it's not considered acidic or basic necessarily. In this water-based solution, there are compounds produce ions, positive and negative ions. Remember that an ion is a charged particle, positive or negative. The strength of an acid or base is not the same as a concentration. You can have a little bit of acid and be very, very strong. And you can have a lot of acid and be very, very weak. So we'll talk about that a little bit. So let's move on to what are some acids? How do acids be produced? So in HCl, if it's in a solid state, would look like this. So when HCl, hydrochloric hydrochloride is in water, it dissolves into H pluses and chlorine minuses. So these H pluses is what the acid is focused on. So in water, acids release a proton, H plus, into the solution, and that is determined how acidic something is. So if it has a lot of H pluses, then it is very strong. In a base, NaOH, that's sodium hydroxide, is released in water into sodium ions with HO negatives. So hydroxides ions are negative. So this is the positive charge. This is the negative charge. And these are the base ions that we're looking for, the OH minuses. So let's see what it looks like for positive, so strong and weak. So in this situation, we have HCl in water is a very, very strong acid. Those hydrogen ions separate from the chlorine ions and become, almost all of them are separated. So very strong acid. A weak acid would be this, the HC2H3O2. It's a weak acid. And this acid forms very few hydrogen ions, and that's the H out in front. So it's just C2. This negative ion right here would be C2H3O2 negative. And that's a very weak acid. On the other hand, we have very strong bases versus very weak bases. So a very strong base has a lot of OH negatives and then whatever the positive ion is with it. So in this situation, it's a sodium ion, and the OH negative ion is what we're looking for bases. And this is sodium hydroxide, like we just talked about in the last slide. And this is ammonia, which is NH3. And in this situation, we have very little, it's a weak base, but it's very little, this is actually NH4 plus, and this is OH minus. So this is taking from the water molecule an OH and giving the H plus to a ammonia atom and molecule. And so this is a very weak base and very little OHs. So talk about a litmus paper test or a pH scale in acids and bases. We have acids turn red litmus paper. They keeps red litmus paper red, but it turns blue litmus paper red. And then a neutral solution would keep the red litmus paper red and the blue litmus paper blue, meaning it's a very neutral solution. Distilled water is at a neutral solution. And then we have bases. Bases will turn red litmus paper blue, and it will turn blue litmus paper. It will keep it at blue. So these are just a quick test for an acid neutral base. You wouldn't want to use this to find out how strong or weak an acid or base is. You just want to use it to find out if it is an acid or a base, or if your solution is neutral. Let's talk about how a weak or a strong acid or weak or strong base would be determined on a pH scale. So a pH scale is from 0 to 14. And the 0 to 14 scale is based on an hydrogen ion concentration. So in the solution, depending on how many hydrogen ions are being released in the solution, depends on the strong the scale, how strong or weak an acid or base it is. So in this situation, we have our strong acids on a 0, 1, 2, 3 scale. 3, 4, 5, 6 is a weak acid. Neutral are right there in the middle at 7. 7 is distilled water. Then we have some weak bases, 8, 9, 10, 11. And then some strong bases, all the way up to 14, 11, 12, 13, 14. So we have our strong and weak scale. Per hydrogen, we don't know where the small p comes from, but the H stands for hydrogen. So I call it per hydrogen scale, depending on how many hydrogen ions there are. And that's the end.